In this video, I will solve 6 class practice examples for solving absolute value equations. Go ahead and check out the previous video for my 2 steps for solving and then how you know how many equations to set up. So for letter E, I noticed that my absolute value is set equal to a positive number, and so I know that I'm going to have 2 equations because 8 is a positive. So inside here, this could have been 8 or -8, and what I'm going to do is solve for that. I'm also not going to be graphing my solutions here. So for my first equation, I'm going to set up that my x minus 4 could have been 8, and then for my second equation, the x minus 4 could have been -8 inside the absolute value to pop out a positive number of units. And so how I'm going to solve is by adding 4 to both sides. And one solution I'm going to get is the solution of 12. And for my second example here, my equation to solve, I'm going to add 4 again to both sides. But my other solution would have been the number -4. Now for letter F, I have 2 kind of reminders here for you. Look at your absolute value plus 3 is equal to 14. Before you set up your 2 equations, you need to isolate the absolute value. So we have to get rid of that 3 first, and then we will write our 2 equations. So if we subtract that 3 over, our absolute value of 5x plus 1 would be equal to 11, and this is what I'm going to use to solve to set up my 2 equations. If you don't isolate first, one of your answers will always be wrong. So my 5x plus 1 could have been 11 or -11 to pop out of my absolute value bars and 11. So I'm going to set 1 equal to 11, and then my 5x plus 1 I'm going to also set equal to -11. So now I'll start solving. I'm going to subtract 1 on both sides, and I'll get 5x equal to 10. And now if I divide by that coefficient of 5, one of my answers could be the number 2. Over here, like I said, our steps are going to be the same, but notice how we're going to get a different answer here. In this case, 5x could have been -12, and now when I divide by the coefficient of 5, my second solution could have been -12 over 5. Okay. We have a few more problems for practice here. Now take a look at this absolute value at the top on the next page. When you see an absolute value equal to a negative, what we're talking about is distance. And distance cannot be a negative amount of units, so our answer here is just no solution. We are not going to set up any problems to solve because an absolute value can never equal a negative. It's impossible. Now for letter H, notice how in this case I don't have a positive or a negative, I have 0. And when you see an absolute value equal to 0, you're not going to set +0 or -0. This doesn't make any sense. And so we're only going to set up one equation. So our x minus 6, I'm sorry, that was a plus, could have been equal to 0. And now when I solve, I'm just going to subtract 6. And so my solution is, my one and only solution is -6. So because 0 cannot be positive or negative, you just get one answer. Now for the next one here, notice that our absolute value is not isolated on one side of my equation. So before I set up my equations to solve, I need to first add 1. And so instead I will be solving that x plus 4, the absolute value of x plus 4, could have been, actually this is going to be, I almost wrote the wrong number. It could have been 6. And so I'm going to set up 2 equations and then solve. Because this inside here could have been 6 or -6. So here would be one of my equations. X plus 4 could be 6, or my x plus 4 could have been negative 6. And now when I solve, I'll subtract 4. So one solution could be 2. And my other solution here, so notice how my operation is the same, but notice how I'll get a different answer. It could also have been negative 10. Now for the last example over here, letter J, I have a coefficient in front of my absolute value bars and I have a number. And so to solve, I need to isolate that absolute value before I set up my two equations to solve like I did over here. So just like an equation like negative 3x plus 4, I'm going to start by subtracting 4 on both sides. So if I subtract 4, I'm going to get negative 3 times my absolute value, 2m plus 2, and that will equal negative 30. And then if I divide by the negative 3 coefficient in the front, I'll have my absolute value of 2m plus 2 set equal to positive 10. Now because this is a positive, I can set up my two cases. So what's inside of here could have been 10 or negative 10 to pop out as an answer 10. So one of my equations that I'll set up will be 2m plus 2 could have been positive 10. My second one will be 2m plus 2 could have been negative 10. And now I'll solve to get my two solutions. So I'm going to subtract 2 on both sides. And here I'll have 2m is equal to 8. And then if I divide by 2, my solution for one of my equations would be the number 4. And then again, if I solve my other equation and I subtract 2 on both sides, I'm going to get 2m is equal to negative 12. And if I divide by the coefficient of 2, my other solution is negative 6. Now I have one more example for you down at the bottom of your note sheet, and it says error analysis. And the goal here is to circle the error in the work shown below, and then what I'm going to do is rework the problem to get the correct answer. Now if you notice, our absolute value is very similar to this letter J example that we had here. And so if we start by subtracting 5, 32 minus 5 is in fact 28. So I know that that part is correct. But now if I take negative 4, my coefficient, and I divide by that coefficient on each side, I do get negative 7 for this side. But here's where the error is. If this is what your absolute value is, you cannot set up two cases. So we should have stopped here, and this is where your error lies. If you have an absolute value equal to a negative, you should stop right there and you should say no solution. Because an absolute value of a negative number, it's impossible to say that a distance represents a negative unit, and so we would say no, this should not have been done here. They should have stopped at that point, and instead of working out for two solutions, they should have said the answer is actually no solution at all.